All right. Hi, everyone. My name is Elizabeth Bondi. I'm a fifth-year PhD candidate at Harvard School of Engineering and Applied Sciences. And today I will be talking with you about trying AI for social good. So during today's talk, I want to first start by talking about what is AI, or artificial intelligence. And then I want to talk about how can AI help society, or what we mean by social good, for example. Then I want to talk a little bit about how you can learn more if you're interested in doing so. So just to jump right into the question of what is AI, or again, artificial intelligence. So you may have already heard about AI in pop culture references. There are sometimes some bad AIs like Ultron or the Terminator, but there are also sometimes some good AIs like Cortana or Wall-E who might try to help us out as humans. But you also probably have used a little bit of AI in your life as well. So for example, you might have used voice assistants like Siri or Alexa, and you might have even interacted with AI a little bit when you listen to music on Spotify, because it might be recommending certain songs or podcasts to listen to while you're on Spotify, or even something like Netflix. But let's really dig in and talk about what is AI for real. And I want to emphasize that AI is not a being, it's actually a tool. And in particular, AI is math that humans design to map information to decisions. And humans, in fact, also implement this math that we come up with using code. And we will get into some examples as we go, but at a high level, I just wanted to provide some examples of AI and math, and in particular, the algorithms that we can use to map information to decisions. And algorithms is sort of like a fancy name for the math that we're designing. So if we look over here, we can see in the left side of the screen, we have a bunch of cats and dogs that we don't really know what they are, and maybe we want to automatically determine whether they are cats or dogs. So we can develop one of these algorithms, we can make some math to help us automatically determine what is a cat and what is a dog. And of course, we might make a few mistakes, but the goal is to try to do this as efficiently as possible using AI. We might even be able to use AI to help us make decisions about playing a game like tic-tac-toe, for example. So if we have a certain board, maybe it's empty, or maybe we've already put a position down, we can then try to figure out with the help of AI which move might be the next best one to make. We can even use AI to make some more complicated decisions. For example, trying to figure out where your self-driving car should be going next, or whether it should be stopping to make sure it doesn't hit something. And so now I want to talk a little bit about some other uses of AI in the real world that you may not have heard about before. So lately, of course, we're all being affected by COVID-19, unfortunately, but AI has been used to try to help model the spread of AI, as an example, to try to help us figure out whether we should be doing certain lockdown procedures or restrictions to help prevent the spread, for example. And if you're interested in learning more about that, that's something that you could search for our group on our group's website on teamcore.cs.harvard.edu, as some of my colleagues in the lab have worked on this a little bit. AI has also been used for school choice and trying to make sure that as many people get to the certain schools that they would like to go to as possible. And finally, another really interesting and more specific example is AI being used to foster art and storytelling. And so I highly encourage you to check out this website by Stephanie Dinkins to talk more about this project in particular. And just to give an example of what it does, it talks a little bit, it tells the story of a multi-generational Black American family and you can interact with it by asking questions. So all of those are kind of cool applications of AI in the real world, in things that you might not have heard before. But what I want to focus on today is some of the work that I do in AI for conservation. So with that, I will go into a more specific example. So with conservation, what I'm going to talk about in particular is wildlife conservation. And so this is the idea of trying to protect endangered animals like elephants from extinction or from losing further biodiversity in general. And one of the ways that people are trying to prevent biodiversity loss in the field is by using drones. And so you might be wondering, what can drones do to try to prevent losing wildlife? And so what they can do is fly around national parks, and they can try to monitor the parks to see what's going on. We might be trying to do things like find elephants in the park and count how many there are, just to see how they're doing. We might also be trying to look around for potential wildlife poachers to make sure that animals aren't being killed for things like ivory, for example. So we can fly these drones around, and like I said, we can monitor what's going on in the park. So this is done by having a camera aboard our drone, and as we fly, we might get an image that looks like this one. This is a thermal infrared image, and we can actually see some elephants in this image right here. Hopefully you can see me highlighting them. They're the sort of bright white spots in the image. And the reason that they're brighter than objects in the scene elsewhere is because they are warmer than some of the other objects, like these trees that you might see, or this little road here. And so what we could be doing is watching the videos that we get from these drones that might look like this, and then we can use that to see that there are some animals here. Like I was just saying though, that might involve flying our drone, sending information like our videos back in real time to people who might be watching these videos, as long as you want to monitor something. That could be all night long, for example. And I don't know about you, but that sounds a little bit tedious to me, to have to stay up all night watching these videos that look kind of difficult to find things in. Another challenge that we have in using drones for conservation is to try to figure out where we should fly the drones in our park. So here, I've represented a park just as a simple grid, where each of these cells is representing a location in our real park. And so, for example, we might find that there are some elephants located in our park, and we might need to figure out where we should fly the drones. As you can see from this illustration, there could be a lot of cells to visit. Maybe we don't have enough resources to visit all of them, whether it's enough drones or even enough battery power. So we can actually use AI to try to help address both of these problems. So first, let's talk about this challenge of watching these videos all night long and see how AI can try to help us do that automatically. So in particular, like I said, we're going to try to use AI to help us look through these images automatically. What happens is we're going to create an algorithm to classify these images. And that could be saying that they're an elephant, or saying, oh, that's just a tree, it's not actually an elephant. And when we see an elephant or any other animal that we're looking for, we can then just generate an alert to a human to double check what they see and make decisions from there. That way they don't have to be watching the video all night. So we can create this algorithm. It might look something like this, where we have an image, and then we have all of these different mathematical, basically combinations of some of the pieces of the image that eventually give us a box that we draw around our object of interest, like an elephant, and tell us what's in it, like an animal or an elephant again. We can implement this algorithm that we come up with using code, and then we can just run this code while we're flying the drone in real time. So to try to help this process, we also did some testing in simulation with a tool called Microsoft AirSim. And so a video of that is shown here on the left. Someone is actually flying a drone around a basically video game environment, in particular an Unreal Engine environment, which you may have heard of from Fortnite, for example. And so we're flying this drone around in this environment, and we're getting images as we go that show us what the drone is seeing. And so we can actually use this to figure out how well our algorithm is doing by making some synthetic images. And we did this by actually using an Africa environment that we built, similar to this one that we can fly around in with our drone. And again, we can test what we're coming up with. We can also use it to get more data to try to improve our algorithmic performance. And so once we do all of this to try to get a good algorithm, get together some good math to make this process easier, we can actually get some results that look like this. So here we have some elephants that we've detected, and the fact that they're in green boxes tells us that we're detecting them as animals. And then over here we have some humans that we've detected, and that's indicated by the fact that they have blue boxes around them. So all of that work to try to do this automatically and provide alerts to humans so they don't have to watch these videos all night long. The other thing that we are talking about then is determining where to place our drone. So maybe we have a bunch of different locations in our park. We could represent this as a grid or some other kind of model. And then the algorithm that we use to try to solve these challenges is game theory in my work in particular. We won't get into the details of game theory, but you're very welcome to check that out in your spare time if you're curious. But anyway, we use this as our algorithm, and our goal again is to figure out where we should fly the drones using some of the information about what's in the park. We might also want to know what we should do if we do see something like an animal or a human, and we may want to turn the lights on aboard our drone to try to, for example, prevent humans from doing poaching by sort of signaling to them that maybe some park rangers are on the way, thanks to our system that we just talked about, potentially detecting them. By doing this, we hope that we can prevent poaching from occurring in real time. And again, we can use AI to help us figure out where we're going to place our drones and whether we want to turn the lights on or not, as an example. So now I want to get into a demonstration where we talk a little bit more about the code and the math that might be involved in trying to do something like this. So in particular here, we're going to try to figure out where we should place our drone in this park, which again is represented by a grid here. And we have a few elephants located throughout our park in this grid. We have 2 here, 3 here, and 1 here. And we don't have any in the rest of the park. So my question to you is, where should we place our drone to try to make sure that we will see elephants? I'll give you just a second to try to think about that. All right, so we are going to place it right here. And if you remember, this is where we had the 3 elephants. And so this has just been replaced by some colors instead of the images of our elephants. And that is simply because we can represent it a little bit easier. So we have more elephants where we have green, and we have no elephants where we have red. So we have less elephants here in the light green and less elephants here in the yellow. And again, we placed our drone at the position where we have the most elephants in this case. Okay, cool. But where should we go next if we can only move 2 more steps? Let's say our battery is running out or something like that. And just to clarify, 2 steps would be moving 2 locations. no diagonals. So 1, 2 is another option. I'll give you another second to think about it. All right, so if we have 2 steps, that means that 1, 2, we can't get to this next most number of elephants. That means the best thing that we can do to make sure we see elephants is go down. Now we've flown our 2 steps, we see 1 elephant, which is better than no elephants here. And so, yay, we found some more elephants to help us understand what's going on in the park. All right, so now we've seen what we can do to try to place a drone when we know where the elephants are located. But what happens if we don't know where the elephants are located? In this case, let's look at an example where we can predict how many elephants we have, and then we can decide where to fly. Again, with the goal being that we're trying to count the number of elephants that we have in our park. For example, to try to see how healthy the population of elephants is. Here we're going to switch over to a code demo now. All right, so just to reiterate, this is the PowerPoint example that we just discussed, where again, we have our elephants and they're being represented now just by these colors over here. We have more elephants where it's green and less elephants where it's red. This that we're looking at this in is called Google Colab, and it allows you to run Python code in this IPython notebook. This is something that we'll be able to share with you after the talk. But if you're used to code, then you might recognize some of the stuff that I'm doing here. And so first I'm importing some of these packages that we need to run this code. Then what we're going to do is basically make another version of this, but we're just going to do it automatically. We're going to automatically generate how many numbers of elephants are in each of the different cells in our park. That's going to happen right here. We're also going to generate some other information in our park, such as elevation and the amount of water, for example, rainfall. And so what will happen here, the reason that we're generating this other information about our park is to try to help us when we don't know exactly where all of our elephants are, like we said in the PowerPoint. So that's what's happening here. Let's say we only have data for the top left corner, but we haven't explored the rest. So we're going to just pretend that we've seen the top 3. So what we're going to do is display this map that we just created, and it'll look something like the following. And again, this is different from the example that we did in our PowerPoint, but it represents a similar thing. So here we're seeing that there are 4 elephants, same as here. We have about 3 elephants here. We have about 1 elephant here, and we have no elephants here. And so what we're saying is that we only visited this top 3x3 portion of this grid. We've only walked around as park rangers, for example, and counted how many elephants are in each of those squares. We haven't visited any of these other grid cells out here, so we don't know what's happening here exactly. We've also generated some information about the elevation, like we said. By elevation, I just mean things like hills, for example, in the park. And we also have some information about our water, seeing where water is located in this park. So the next thing that we'll do, and again, our goal at this point is to use this information about water and elevation and the information that we have about where elephants are in just this section that we visited. We're going to try to figure out about how many elephants there might be in some of these other portions in the park, even though we didn't get a chance to walk around in those sections. So to do this, we're just going to do some quick rearranging here, which I welcome you to check out offline to see how we're doing that. But basically, what's going to happen after we do some of that quick rearrangement is we're going to try to fit a machine learning model where we have the known elephant data. So that looks like we have this linear regression model in particular, and we're going to train it by using just this top 3x3 section where we visited again, up here. And we know, again, how many elephants we have there. So that's what this Y represents. This X represents our elevation and our water. And we're going to then use this fitted linear regression model to make a prediction. And this prediction is going to happen in the region where we have not visited. And we're just going to use the information that we have about our elevation and our water in those locations, right? So once we have our predictions, now let's check out what we came up with. So first, we'll look at our full predicted elephant distribution. So here we go. This right here is what we've predicted throughout everything that's happened. We already know what's going on up here, but we still made some predictions based on our elevation and our water. But this is an area where we never visited, and we're just trying to make guesses about it based on, again, our elevation and water. This is the map we started off to begin with. So you can see how these look very similar up in the top right. And this is the area that we didn't know about. So now we can decide where we should fly our drone, because we just tried to figure out how many elephants we have in our park. And what we're going to do, we're just going to do that very first step we did last time, which is choose the maximum number of elephants in our very first step. And so we are able to do that with this line of code here. And finally, we can display the location that we chose. And again, this is just taking the maximum number of elephants. So in this grid, the maximum number of elephants is right here. We have 4 elephants here because of this green color. And so now we can display where our drone is going to be placed. And you can see that it's placed right here, which is just where we said it should go based on our results from our predictions. So just to summarize, we have used data that we have just from this small region of our park or our grid. And we've also used some information about the rest of the park in terms of elevation and water. We fit a linear regression model to figure out how many elephants are in these portions of the park where we don't have any information ahead of time. And we went ahead and chose a location to fly our drone based on the maximum number of elephants in a location. And so once I share this code with you, I encourage you to explore it, try to figure out what's going on throughout, and see if you can maybe find the next location where you could go. You can even think about more complicated scenarios. Like we said before, in some of my work, I use game theory algorithms to figure out where we should be flying. Or we can use deep learning algorithms to figure out what might be happening in some of these other regions in the park with more complicated information. You could imagine maybe a drone flying around, for example, not just going to one location. So that is just a quick preview of how you might be able to use AI to solve a problem that society might be facing. Now let's go back to our presentation. And let's talk about what you can do to learn more. So first of all, like we just talked about, you can play with the demo some more. But to talk a little bit more about what else you can do, I want to give you an idea of what I did when I was in high school to decide how to learn more. So I grew up in upstate New York in a small town, and I really enjoyed my math and science classes in high school, but I just wasn't sure what to do. So what I ended up doing, I found an internship opportunity at the local school in Rochester, New York, called Rochester Institute of Technology. And they had a bunch of interesting applications that really appealed to me, such as finding hidden text in ancient documents. And so I applied to this internship opportunity, And I was able to join a lab and do research with a professor and other people in their labs, such as postdoctoral scholars and students. I was able to do research that whole summer and figure out that I really liked doing research. I really thought imaging science in particular was cool, where we did things like look again for these hidden texts in ancient documents, look for things in medical images, look for remote sensing information that we might collect from things like satellites or the drones that we just talked about. And again, I did this internship, I really enjoyed that research, and so I decided to go to Rochester Institute of Technology for my bachelor's degree. And then I became, after becoming interested in that, I continued to do research throughout undergrad and grad school. I went to USC and now I'm at Harvard, like we said. And eventually I hope to become a computer science professor. So now let's talk about what you can do to learn more based on some of those experiences that I've had. I think that it's really helpful to talk to family, friends, teachers, and professors. Even consider reaching out to local professors in your area if you'd like to learn more about either AI or other kinds of math or science or anything really. I also think it's helpful to learn to program. And so anyone who's participating in the Open Code Foundation already has a leg up there. And I encourage you to check out other resources too, if you'd like to learn even more. There's also internships, which is the experience that really helped me in high school. And so there are some summer programs available from the organization called AI for All, which you could check out. I also have been trying to put some together in a program called Try AI, which I'll provide the link to later. You can also join clubs, participate in hackathons, and seek out other organizations to help educate you in STEM or AI. If you already feel like you have a lot of experience in programming, then you might also be interested in trying to apply some of your skills to some open source data sets. And so here I've just included a bunch that have to do with conservation in particular, like the example we went through today. Several of them are for camera trap data. And then there are also some that come from photographs. The goal in many of these is to try to identify if there are animals, and if so, what kind, maybe even which individual. Like here, for example, we try to figure out which individual zebra we're looking at. And finally, this data set is one that I've worked on, which contains other thermal infrared images like the ones we looked at today. And if these aren't so interesting to you, there are even more data sets on conservation at lila.science. So I encourage you to check these out. If you are still working on learning to program, and you may not feel comfortable getting started on one of these data sets right away, then these are some other resources that you could check out and participate in science. This is called Zooniverse. This is called NASA NemoNet. There's also iNaturalist, which is an app that you can download on your phone to take pictures of things that you see in nature, and Penguin Watch. And these three are primarily trying to help scientists by picking out, for example, where there are penguins in images. And so with that, I just want to give everyone a big thank you for tuning in and encourage you to reach out to me if you have any questions whatsoever. This is my email and my Twitter. And then this is my website where you can find this code demo once we're done with the talk. And you can also look for that data set we discussed. And finally, check out the Try AI website if you would like to see some more potential opportunities to try AI for yourself. Thank you again. Bye.